this. Okay, so what we learned from the concept was we are taking the sample from the population, and then we take the average of sample, and then also we calculate the standard deviation of that sample, and then we calculate the estimated standard deviation for all the samples based on the variance or standard deviation of that specific sample that we chose. So how we calculate the standard deviation of all the samples? By the formula of a standard deviation of that specific sample that we chose, divided by square root of the number of observation that we have, the sample size, right? So what I'm going to give you here in this example is number of the generators that each state has in order to produce the electricity is based on the real data. So if you see all of them, for example, so many of them are Arkansas, the reason is because Arkansas also have different county. I didn't bring that, but it shows like, for example, in each county, how many generators they have. So that's why it is based on the real data. So you have 300 observation in this example. So 300 observation, and now we are going to work on our example on taking the sample with different sample size. So the first sample size that I chose was choosing 20 observation. Now I'm randomly, it's totally up to you, randomly choose 20 units of this 300 observation, or 20 observation out of that 300 observation. So I chose for my first sample, just totally random, from D280 to D299. So it includes also 280, so that's why I have 20 observation. I take the average for sample 1, and then also calculate the standard deviation for my first sample, D280 to D299. So I take that as well. And also I'm going to take another sample. So I take this first sample, I take another sample as well. I take sample 2, this time from D15 to D34, totally random. You can also do the same thing, totally random, choose 20 observation. I take the average of that. I also take the standard deviation of that. Okay. I also take the average of my 2 samples that I chose. The first sample, the average was 2.75. The second sample, the average was 3.65. So the average of them is summation of these 2 divided by 2. So I have the average of 2 samples, which is 3.2. Now I want also take the standard deviation of all the samples based on the sample 1 standard deviation, or based on the sample 1 variance. How I can calculate it? So the calculation is a standard deviation of my first sample, this blue one, 1.888, divided by a square root of the number of observation that I have in my first sample, which is 20, right? So in order to have in Excel, in order to have a square root, just type SQ, and then it shows you SQRT. So choose that, and then choose the number that you want to take the square root of it. So in the first sample size was 20, so I chose 20 here. Now, if I hit the enter, that gives me a standard deviation for the units for all the samples based on the sample 1 variance. I do the same thing for the sample, calculating again the standard deviation for all samples, this time based on the standard deviation of sample 2, which was 2.084, divided by a square root of 20, or H6, which is this red one. Hit the enter. Okay, now I want to see that how much is the probability in order to have equal or greater than the average of sample 1. Sample 1 was 2.75. I want to see how much is the probability if I choose any sample that has the average equal to 2.75 or greater than 2.75, how I can calculate it. In Excel file, you can write this formula. Remember, we were calculating the norm distribution. So you are calculating the cumulative part, but because we want to see the greater or equal, that means all the right tail of our normal distribution. So we need to write 1 minus, open the parentheses, normal distribution. So normal distribution, our X is the average of our sample, because here asking for sample 1, average of our sample 1, and then comma, average of our whole population, comma, the standard deviation of all the samples that we just calculate, comma, cumulative or true, and then close the parentheses and close the bigger parentheses. So 1 minus that. So there is 97.3% chance that any sample that you are choosing has the average equal to 2.75 or greater than 2.75. How about sample 2? Sample 2, the average was 3.65, right? Let's see how much is the probability to have any sample that has an average of 3.65 or greater than that, okay? Again, I would write the formula 1 minus, open the parentheses, normal distribution. The X, you see here, X is the average of sample 2, comma, the average of sample 2, average of the population, here, 3.56, comma, a standard deviation that we just calculate, comma, cumulative, close the parentheses, and close the whole bigger parentheses. So there is 42.4% chance that if I choose any sample, the average could be 33.65 or higher than that. Any questions so far? Let me check the chat if you have any question. Any question? Okay, if you don't have any question, I'm going to increase the sample size. This time, the sample size is 60 units. So I increase the sample size. I do the again, same thing, but this time I'm choosing 60 units from my sample, from my population. Here, for example, I chose D3 to D62. You can choose any other, but make sure that you have 60 observation in it. And then I take the standard deviation of that. I do the same thing for the sample 2, 60 units. This time I chose from D100 to D159. I also take the average of our samples. One of the sample was 3.85. The other sample, the average was 4.15. So here, the average sample is 4. What I learned here is, looks like when I increase the sample size, I have more close to the average of my sample is closer to the average of my population, you see here. So now, again, I calculate the standard deviation of all the samples, which is the standard deviation of the sample that I chose. For example, sample 1, the standard deviation of that. Sample 1 here, divided by a square root of 60. Do the same thing for the sample 2. Standard deviation of sample 2 divided by a square root of 60. Okay. Now I want to calculate what is the probability if we take any average, any sample average that would be greater than or equal to 3.85, sample 1 average, right? I want to calculate that probability. So I would say 1 minus normal distribution of X, which is 3.85, comma, the average 3.56, comma, the standard deviation that I calculate 0.311, and choose the cumulative or true. and close the parentheses. So there is 17.6% chance that any samples that I'm taking has the average of 3.85 or higher than that. I do the same calculation when I want to calculate what would be the possibility or what the probability if I choose any sample that has the average equal to average of sample 2 or greater than that. What was the sample 2? Sample 2 was here. It was 4.15. So I want to see how much is the probability that I choose any sample that has 4.15 as their average or even greater than 4.15. So again, I calculate that by using the cumulative normal distribution cumulative formula in Excel. 1 minus the norm, X would be the average of my sample 2, comma, the average of my whole population, comma, the standard deviation of my sample 2, and then true, close the parentheses, enter. Let's see what is the question that we have. Let's see what is the question. Is there a reason I keep getting 0 for a standard deviation of number of units for all sample? I think if you get the 0, maybe you are not having the decimal. So right click on that, format cell, and go to the number, choose 3. Let me do this here, you can see. So if you get 0 here, that means your number is just for 1 decimal. So I right click on that, format cell, and then here on number, choose 3 decimal, and then OK. And then it shows 3 decimal for that, not just 0. Did the problem solve? Let me know if your problem solved. So now we increase the sample size to 100, and then we do the same calculation. So if you don't have any question, now I want you to open the classwork that we have and start to work on that using the 20 sample size, 60 and 100. Let's see. So you can do the same thing for the classwork and let me know if you have any question. Let me solve the problem for one question here. Oh, good question. So yes, after you did your classwork, just submit it on the assignment part. This is not the assignment. So this is just part of your participation. I also don't grade that, right? But I just want you to work on this and submit it on the classwork part of the assignment. It says classwork, just submit it there. Whatever you worked on that. You have the due date tonight until 11:59. I'm not grading that. That's just participation. And on Monday, we go over that and solve it. So as long as you follow the formulas, you'll be fine for the classwork as well, very similar. The only difference is in the classwork, you can choose which number you want to choose, like totally random. For 20, when the size of the sample is 20, when the size is 60 or 100, you are choosing whatever you want to choose. From the middle of the data, from the end of the data, it's totally up to you. Let me quickly stop sharing and check my mail. If you send anything to me, I can see it. So if you have any questions, since I cannot check your work, come to your computer, you can just send me text in the Zoom on private, and then I can check it